Hi guys, welcome to this video where we're going to be looking at radicals. I'm sure all of us have seen radicals before. They're always written like this, a root, yeah? So if you have something like this, x, this is what we call a radical, yeah? This is our radical, and then we call this the radicand, whatever is inside. We're going to call it the radicand, and then whatever is here, we're going to be calling it the index, yeah? So for example, if you have, they tell you to find the square root of 4, yeah? The index, whenever you don't see an index, it's square root. So meaning you just assume the index is 2. But if they want you to find the cube root of any number, x, they'll put 3 here. So we call this the cube root, we call this the square root, yeah? And then we call whatever is inside the radicand, and this is the radical. So all this is going to make sense. Another thing I want us to remember is, what is a perfect square? We're going to start from there. A perfect square is a number whose square root is a whole number. So we have, these are the perfect squares: 1, 4, 16, 25. They go on, 64, right? So they go on. So why is 1 a perfect square? Why? Because the square root of 1 is plus or minus 1. So this is a whole number. Why is 4 a perfect square? Because you can get the square root of 4 and it's a whole number and it's plus or minus 2. So we call these perfect squares. Let's go on, introduce our content. So sometimes they're going to tell you to simplify, right? So they tell you simplify, what's the square root of 16? So you see there is nothing here, there is no index. So we call this a square root. We assume the index is 2. So the square root of 16 is a perfect square, and it has a square root plus or minus 4. So that's a square root. What about 400? 400 is a perfect square. Now, this is the same as telling you 3 times the square root of 400. What they're telling you is get the square root of 400, and whatever you get, multiply it by 3. So the square root of 400 is 20, right? So 3 times 20, and this would give you 60, yeah? Now, there are some times when you don't have perfect squares, right? So this is a perfect square and this is a perfect square. Sometimes you don't have a perfect square. So for example, 48. So they tell you to find the root 48. Whenever you know that the radicand is not a perfect square, this is what you have to do. Tell me 2 numbers that you multiply to get 48, and one of them is a perfect square, and it has to be the highest there is. Which 2 numbers are those? 16 times 3, I get 48. So meaning if I get the square root of 48, it's a matter of putting a square root here and the square root there. But then 16 is a perfect square. That's what I wanted. I wanted for one of the factors to be a perfect square. So 16 is a perfect square, you get 4. So 4 root 3 is what it simplifies to. Does that make sense? So I'm breaking this root 48 down, and then I'm getting, if you simplify it, you get 4 root 3. Let's look at another number. So this is the same as writing negative 3 times the root of 28. Is 28 a perfect square? No. So I need 2 numbers. When I multiply them, I get 28, and one has to be a perfect square, the highest perfect square. So you can multiply 4 times 7. So meaning if I get the square root of 28, this will be the same as the root of 4 times the root of 7. And what is the root of 4? It's 2. So this is the same as 2 root 7. But don't forget this negative 3, right? There's a negative 3. That means negative 3 root 28 will be negative 3 times 2 root 7. So here you multiply what is outside the root together and what is inside the root together. So here, these are outside the root. This doesn't have a root. So it will multiply with this 2, but it won't multiply with the 7. So this will be negative 6 root 7 as the answer. So that is how we're going to be simplifying non-perfect radicals. All right, guys, thank you for watching. See you again in my next video. Bye.